Hey everybody, welcome back to the channel. In today's video, it's going to be the first of a two-part series for the Sony set that I have in for restoration. The first of which being a TAE-8450. This is a flagship preamplifier from Sony from the mid to late 1970s. And it was the matching preamp for the very notorious TAN-8550 VFET power amp. This one is going to be the second video in the series. It's going to get the full restoration as well, so I'll keep an eye out for that after this video is posted. But getting back to the TAE-8450, this thing is ginormous. It's huge, and it has everything you'd expect in a full-fledged flagship preamplifier from the 70s. It has EQ stage for both left and right channel, filters, tape loops, multiple phono inputs. It has selectable gain and sensitivity on the back for the phono stage. I mean, this thing has everything. Tons of knobs, tons of switches, and that means lots of things to do. Lots of stages to rebuild, controls to clean and lubricate, and even down to the cosmetics. There's tons of switches and controls that need to be pulled off and cleaned and polished. But that's going to be one of the last things I do. This thing is in really good shape, actually, which is surprising. The feet on the bottom, a couple of them were cracked during shipping, but that's the only issue that that this thing sustained. It was packed pretty well. I'll spin this around and show you. One other thing this has is trimmers for each line input, which is pretty cool. You have selectable impedance and sensitivity, as I've mentioned, and has a pretty cool ground connection on the back, which is actually just a push button. So if I haven't mentioned it before, this thing's going to get a full restoration from top to bottom, just as I usually do. I think this might have a channel out. I was talking to the owner, and I think he mentioned that one of the channels was dead. So it's going to be interesting to chase that down and see if I could troubleshoot it, if it is an issue. And these series from Sony actually have a pretty cool VU meter circuit. It uses something like an analog VU meter, and it incorporated into like a digital display. I think they called it a PPM VU meter circuit, which is pretty complex. It's a module that sits up front. So I might dig into it, but I'm not sure yet, depending on if it works. Some things are pretty apparent. The volume control is pretty loose. It's probably the mounting nut on the front has become loose over time, or it could have been damaged from shipping. But I won't know until I pull everything apart. Along with the equipment, I also got the service manuals for these. I want to show you how comprehensive Sony was in their manuals. They give you voltages on the schematics in most locations, around all the semiconductors anyway. And they have it all labeled in red. They give you board diagrams with more voltage references to go off of if you're troubleshooting. They give you parts list, and they call it the semiconductors that they use. And they give you, a schematic for each individual stage, which is very helpful. And they tell you the designation on where each component and each circuit leads to in the preamplifier, which is awesome. It's very helpful. They give you block diagrams and chassis assembly diagrams as well. So Sony really did do a lot to help out technicians that worked on their equipment, which makes this job, it's going to make it a lot easier. So I'm going to pop the top cover off, and I'll show you just how special this thing is inside. When you see it, I'm pretty sure it's going to amaze quite a bit of you. The circuit boards are all modular, so you could just take the two brackets off the top, and you pull each individual circuit board out, which makes it very easy to work on, excluding the power supply. So I'll pop the top cover off, and I will show you guys in a second. Alright, so here it is with the top panel removed. And just as I said, the inside is very impressive. It was laid out really well from Sony. All the wiring is wrapped and very neat. All the wires are held on with connectors. The boards are modular. I mean, this thing is just a work of art. Should be very easy to get apart. I know for a fact these boards are modular, so these just slide right out. The only thing that I don't like is the fact that Sony decided to mount the power supply board directly on the filter cap. And that's the only mounting this board has other than the slot that's in the chassis itself. So I'm hoping that the filter capacitor still measures okay, because that's critical for the structural integrity of the power supply itself. If I were to change that filter capacitor out, I'm not sure how I'd end up mounting the circuit board inside the chassis. So we'll cross that bridge when we get to it, but hopefully it's not an issue. And it's a weird filter capacitor as well because it's two caps in one. So it's going to be, like I said, it's going to be very interesting to see how that turns out. But because the filter cap isn't really under a lot of stress, it's all pretty low power circuits. I'm hoping that it's not it's not out of spec. So we'll see when we get to that point. But for now, I just want to show the internal layout. Each one of these circuit boards is a different stage of the amplifier. For instance, I know that this circuit board right here is your headphone amp and your microphone stage as well. And the headphone out, which is right, where is it? Right here. That's powered from this board, and you can see the headphone ICs down there. And it has TO, I think these are TO220. That might be TO126s, but these are forming the current buffer, which is absurd considering that headphones back in the day weren't really that hard to drive. So them using big semiconductors like this is pretty impressive. So, but that's beside the point. I mean, even the control shaft for your phono selector is made out of solid brass, and as is the coupler right down there. Solid brass. And it goes to a beautiful Alps switch. Very impressive. So I'm not sure where to begin because this is such a big preamp, but I have an idea. I'm probably going to start with the daughter boards, and then I'll get everything up front taken out as well. I want to flip this around and show you the bottom side and show you how neat Sony was with their wiring, because you can only kind of catch a glimpse of it from the top. So let's pull the bottom panel off and let's take a look. Okay, here it is with the bottom panel removed. And just as I said, this thing is beautiful. It's literally a work of art. I mean, all the way down to the wire looms that are laced with lacing cord. I mean, you never find that anymore. You might find that in super high-end tube preamps where it's all point-to-point wiring, but I mean, for solid-state equipment, this is absurd. This is borderline as nice as avionics equipment. I work in the aerospace field and I work with aviation equipment all the time, and some of that equipment doesn't even look as nice as this. And the standards in that field are very, very high. So that goes to show how intelligent and how, you know, caring the designers of this preamplifier were from Sony. And even all the way down to the connectors they use. These are really, really high quality connectors, and you can just pull them off the circuit board and remove this board entirely. There's no wires to desolder. There's no connectors that could break. I mean, it's all right here. Just such a nice piece. They really don't make them like they used to. I can see where some people have been in here before. Some of the soldering doesn't look factory. All the original soldering kind of has like a matte finish to it, but toward the back where the RCA connectors are, looks like somebody's been in here before, which isn't a bad thing. It doesn't look bad, but it tells me somebody has been at least trying to troubleshoot probably the channel issue. So we'll see when we get to that point. But yeah, this thing is just so nice. I'm very excited to work on this thing. And one thing I forgot to mention, the factory soldering is actually really nice as well. But I'm going to be redoing it all anyway. But it's just something to take note of. It all looks pretty good. So let's begin the disassembly process. and we'll go from there. So before disassembling the preamplifier, I just wanted to take some quick tests and make sure everything works fine before I start tearing it down. So I have a signal hooked up to the auxiliary input, and I'm measuring the output with my oscilloscope, and I am getting a pretty good sine wave. The controls are pretty dirty though. If I swap the function, for instance, you could see the noise on the switch is going to need to be taken care of, and that's the same with basically all the controls on the front. The power light doesn't work, but the VU meters do. They're going to need to be adjusted. One of them shows a little bit higher than the other one, which isn't an issue. Sony actually goes into detail of how to adjust that in the service manual, as well as the other functions and the adjustments in this amp or preamp. Upon closer inspection, I did see that a couple of resistors in the power supply have gotten hot. These resistors are right on the output of the rectifier, in series with your B plus and your B minus, R902 and R901. And all these are doing are forming a current limiter for your rectifier, as the secondaries of this transformer aren't fused. It's either these are under spec'd, which I think could be the issue, or another issue is capacitors in this preamplifier are starting to get leaky, and what they're doing is they're putting excessive load and stress on the power supply, and in turn these resistors are getting hot. So either way, I'm going to fix the issue. It's not a big issue at all. I see that quite often, so I'll get those changed out when I do everything, and we'll go from there. But for now, this thing seems to be working pretty well. I'm going to measure and test the phono stage and the other stages in this preamplifier, and then I'll begin disassembly. So I have the power supply board removed partially, and I'm just measuring the main filter capacitor. Like I said before, there's two filters in this one can, and they share a common center. So coming up to the LC102, we can see that the capacitor value is within range at 2800. It's supposed to be 33. Coming down to the ESR, we can see that it's good. 0.00 ohms. It's perfect. And if we go up to capacitor leakage, it'll do a leakage test with applied voltage, and we'll see that it comes right down. So this capacitor is perfect. There's nothing wrong with this, and that makes me happy because I won't have to try to retrofit two capacitors and then also try to mount the board. So with that known, I'm going to get this board out and rework that. Also want to show off a cool new tool that I just got. This is a Peak ESR 70. This is a ESR and capacitance meter. So I have it hooked up to the one side of the filter cap, and I'll show you that even on this it measures well. Perfect. Okay, with that out of the way, let's keep going. Okay, so getting down to business here, I have the regulated power supply removed. This needs a basic recap. I'm also going to change the rectifiers out, replace these two resistors that have gotten very hot, remount the regulators on new thermal compound. I'm also going to change out all these small transistors in here. They all have black legs, which is caused by oxidation. And what happens is that oxidation likes to creep up into the actual transistor itself, and that'll give you issues. So those are going to be all replaced. There's two 1S 1555 diodes that I'm going to replace with 1N4148s. And I'm also going to reflow and deflux the back, and that should do it. This trimmer right here I'm going to leave in place. It's a pretty large footprint, and it's inconsequential. All you're doing with this is adjusting the lamp voltage for the VU meters, so it really doesn't really do much else other than that. So that should be fine to leave in place. So with that being said, I have all the parts here, so I'm going to do that and I'll come back. Okay, so I have the board all set to go. Recapped it, all new capacitors throughout. I upgraded the values as well. These two large ones were 470. I bumped them up to 820. Back when this was made, these had to clear the top cover, and the biggest capacitors they could probably fit were 470. So now that times have changed, caps have gotten smaller, I could put in 820s. This one was 330 and I bumped it up to 470. All new T182 transistors throughout. New rectifiers. I have the 2 current limiting resistors installed. The other one's measured perfectly fine, but as you've seen, they're completely destroyed just from the heat. The 2 small signal diodes are also installed. So yeah, this thing's ready to go. Remounted the regulators on new thermal paste. And last but not least, reworked the back of the board. Looks better than new. This is just something I do for all boards. Really makes it pop. Really makes a huge difference in the end. So I'm going to get this installed, and we'll start measuring voltages before I hook the rest of the preamp up. And then we'll go from there. But yeah, not bad for the first board. Okay, I'm back with the 8450. I have the power supply board back in and all wired up. I have the unit on right now. I've verified my proper voltages at my 2 test points. And now I have the meter across these 2 test points right here. And these are for my lamps up front. Now, going off the service manual, they want me to adjust RT1922 for plus 8 volts on the meter. And right now we're a little bit low. So I'm going to turn this trimmer right here to achieve 8 volts. Right there. Good enough. Okay, so now our lamps are at the proper brightness. Alright, now that that's done, I'm going to come back to this tomorrow. We're going to start work on the headphone amp and the microphone card, and then we'll go from there. But for now, everything's looking good. So it's the next day, and I'm starting work on the 8450 again. I have the headphone amp and microphone card removed, and I'm just starting to get the pieces put together. This is just going to be a basic card to restore, just electrolytic capacitors, a few of these carbon comp resistors, and I'm also going to be changing the current buffer on the output of the headphone amp, these 4 transistors right here. These are pretty notorious for deteriorating with age and becoming noisy. They're the C1124 and A706s. So for substitutes, I'm going to be using MJE 15033s and 15032s. And I'll show you where these are in relation to the schematic. So this is your headphone amp right here. And right after this IC comes your current buffer, which goes out to your headphones. And the other channel is identical. So these 4 transistors right here are the suspect transistors that I'm going to be changing. And you can see just how big the emitter resistors are for each transistor. They're pretty big. So this is going to be a pretty impressive headphone amp for a preamp. I'm actually pretty excited to hear it. So I'm going to start on this, and I will come back with an update shortly. I'm just starting the recap on the circuit board here. I have the filter capacitors, the local filtering for the IC chip here, and the current buffers on the output. I have the 100 microfarad capacitors that were originally there. And I have these changed out with 220 microfarad Panasonic FC series, higher voltage as well. And I'll show you the ESR of the old capacitors here. So we're about 0.2 ohm ESR, and I'll compare that to a new Panasonic FC capacitor here, down to 0.08. So these are going to perform better, and they're higher capacitance, which doesn't really make too big of a difference in this scenario, considering this is just a headphone amplifier, but it'll be better nonetheless. So I will get these soldered in here. have a lot of people complaining on other videos that I don't show enough of the work that I do, but it's pretty mundane. My videos are already long enough as it is, and it's basically me just showing what I did. But some people want to see this, so I'll leave this in. There's lots of other good resources out there, especially on YouTube. There's a guy, X-Ray Tony B. He's one of the best YouTubers when it comes to audio repair and restoration. He leaves all this in his videos. But I do this as a hobby, so that's why I record the video. But if you're actually doing this as a main job, recording video really slows you down. So if I were to be doing this full time, I would not be recording the process and, you know, taking videos on everything I work on. It's just a major time consumer, especially the editing and recording multiple takes of each video. Okay, so I have those ones replaced. So I'm going to move on to the other capacitors on this board, and I will come back when I finish those up. Bit of a progress update here. I just finished repopulating the board with new components, including the new output buffer transistors. I have new signal diodes and new capacitors throughout, including a bunch of new film caps. I'm about to start working on the back of the board, reflow and deflux this. You can see it's pretty nasty. It's going to need quite a bit of work. Here's the old parts right here. These carbon comps were way out of spec. Every single one of them were way out of tolerance, so I have new metal film in place. And these orange capacitors in the signal path, these are low leakage caps. And I just want to show you the ESR, this one of them anyway. It's 4.7 ohms. And we're almost at 8 ohms. That's horrible. So the new film capacitors I have in there are like milliohm ESR, so those are perfect. So I'll come back when I finish this board. I'll go from there. So this one's all finished up. It's ready to go. Looks really good. So I'm going to throw this in, test it out, make sure it works, and then we're going to move over to the VU meter control circuit board, which is right here. So I'll come back when I have that out. So it's been about 2 months since I've taken that last video clip on the headphone amp card. I've been extremely busy outside of the audio field with work and studying for exams and getting my power plant license finally. So now that I'm going to have some more time on my hands, I'll finally be able to come up here and sit down and work on this audio equipment and upload these videos for you guys. This is the TAE-8450. I've been slowly going through the restoration on this. I have the headphone amp card done, the VU meter board done, and the power supply all set. You guys already saw all that. And I have the tone control circuit board removed right now. I'm about to start the recap process and the reworking of the back side of the board. So I'm going to keep going with this. Like I said, it feels good to finally be able to sit down and work on audio gear and not have to worry about exams and all that. So, but I still have, you know, my full-time job, my career outside of the audio field. So it's still a little challenging to find time, but now that I don't have to worry about exams and everything, like I said, it'll be quite a bit easier. But yeah, I'm going to keep going on this. And yeah, I have the power amp still sitting over here. I haven't touched this thing yet. The shelves are basically empty now. I've been trying to get the small jobs out. You know, I had a handful of small jobs that, you know, just repairs and whatnot. But the restorations I like to save for YouTube. They make better content as you get to see the start and the finish of it. The last job outside of the Sonys I have is going to be this Onkyo Grand Integra AG10. I'm sure some of you have already seen this from the live streams and the community posts. But other than this, I'm not going to be working audio gear in this location anymore, so I've stopped taking work in for the time being, as I'm going to be moving out of here pretty shortly. So anyway, getting back to the Sony, I'm going to keep going on this, and I'll give you guys an update relatively soon. Here's the tone control circuit board all set to go. I did a basic recap on this one, as well as changing out a couple small caps with films. I reflowed and defluxed the back side of the circuit board, polished the pins. This one's just about ready to go. Just got to solder on this shield right here. I polished this up a little bit. Here are the old caps. I have one of them on my analyzer, and you can see at 53 microfarads it's reading 2.1 ohms, so that's super high. So I have these replaced with high quality Nichicon caps, and the two smaller values I have replaced with the WEMA caps. So I'm going to solder this plate back on. Might as well do that on video. I really love this soldering iron, this FX951. Even with these small tips, I mean, it just really just heat soaks whatever you want to solder with the direct heated tip. I can't recommend this thing enough. I went from a FX888D and then stepped the game up to this 951, and it's one of the best investments I've made so far. I know people say soldering irons don't really matter. You can solder with no-name brand eBay soldering irons, but I disagree. The better the soldering iron, the easier of a time you'll have soldering and doing great work. So now that that's all set, I'll get this reinstalled and I will move on to the next. Alright, I'm back with the TAE-8450. I have all these daughter boards all set, ready to go. Power supply's done. And I'm just about to start the disassembly of the phono head amp card that's buried inside the chassis right there. I'm going to have to take out this very high quality shaft. I think I've mentioned this before. It's solid brass, and it goes to a coupler which gets mounted to a really high quality Alps selector switch there. And that's all just for the phono impedance select for your head amp on the front. Very high quality. So I'm going to get that out. And in the meantime, I just wanted to show you some of the schematics for this. So you can see that Sony really spared no expense in the form of their literature and their service manuals. This thing is awesome for referencing voltages, component values, components, where they go, all the way down to the connectors and the color wires on each connector. A very detailed description and layout of the schematic for each individual section of the preamplifier. And I didn't mention this before, but the owner also sent along the circuit theory along with this. They call it the new circuit operation, printed in the USA. This just basically goes through each individual section of the preamp, from the phono preamp to phono equalizer, high and low filters, even has a section dedicated to the VU meters, also has a headphone driver section, muting circuit. But look at this whole page just dedicated to the VU meters, and a description in the form of a schematic just for the right channel. of your VU meter circuit. It's pretty wild to see that. And you'll never find circuit operation like circuit theory nowadays. The manufacturers just don't really care enough to provide that, especially in the form of a book with schematics in it and really detailed, highly technical explanations of each stage in your piece of equipment. You'll never find that anymore. And when you do, those are the brands that you need to support, because you're not going to find that much anymore. So, getting back to the 8450, I'm going to pull this board out, and when I do, I will show you guys what it looks like when it's out. But I'll show you the back side here. I just love this thing. This is great. And if I wasn't going to go all out on this, there's more than adequate room down here. They have a little cutout in the chassis so you can access the entire circuit board and do troubleshooting, component replacement, everything. You don't find that anymore. And like even down to these modular connectors that you can just pull off the board to remove the board. And I think the front panel is hinged once you remove the faceplate, or you might not even need to remove the faceplate in order to do that. But yeah, I really like this thing. It is definitely a complex preamp. It's more than what I would want for a preamp, but for those that have a lot of sources to plug in and that like the eye candy and the meters and all the knobs and switches, this is definitely not a bad way to go. Just got the card removed. It's pretty easy to take out. Just 3 modular connectors and a small little pin connector right there. 4 screws, and then the board came out. After, of course, removing the coupler from the shaft. It's pretty clean overall. Just going to recap it, change that tantalum out, or actually all those tantalums out. Reflow, deflux, and then I'll make sure none of these transistors are notorious for going bad. And then we'll get that reinstalled. I'm probably going to clean off the contacts on this switch too. All the connectors are numbered. 27, 24, and 26, and they correspond with the silk screen on the board. This thing was really designed to be about as service friendly as you can make something. It's really quite a treat to work on. So here's the board that I just removed. I went through these transistors, made sure none of them were notorious for going bad. None of them have black legs yet, so these are all good to go. They're all high quality Sony transistors, so I don't believe there's a reason to change any of these. So for now, we're just going to stick with a basic recap, remove and replace these tantalums, clean the selector switch here, and give the back a reflow and a deflux. So I'm going to start off with the electrodes, just get those out of the way. Make sure that the board designations align with the capacitor. So in this case, negative is on this side and negative is on that side. So the first one is going to be our 6.3 volt at 100 microfarad. So to change that out, I have a 100 microfarad at 35 volt. And then the next one is going to be our 47 microfarad at 16 volts. Kind of slippery. Kind of have a weird angle going on here with the camera. I'm trying to work around it. Everybody's always telling me to include more of the actual process of the restoration and not just talking, so I'm going to try to include that, at least in some areas. It takes a long time to set the camera up and to shoot the video and to edit it, so not going to see as much as I'd like to, but we're definitely going to try. Next up is these tantalums. So these aren't just in the signal path. I'm pretty sure these are just some local filtering on the board, so it's best to get these out. Usually I'm not too keen on removing tantalums unless you have an issue with them. They're generally pretty okay. In some cases they will fail arbitrarily, but in most cases these are going to fail because of voltage transients. They're very sensitive to voltage, over voltage, and they will short and they will explode if they do. Some people also mention that they can get noisy, but I've never seen that before. The special thing with tantalums is they have a very high capacitance per unit volume. So these are 3.3 microfarads at 16 volts, and they're very, very small. So I'm going to be changing these out with electrolytics, as electrolytics are pretty suitable in most cases for tantalum replacement. But I generally like to keep tantalums, especially if they're in the signal path. I've never seen a tantalum go bad when just used in places like signal path. Tantalums are actually extremely high quality capacitors. They're used in some of the best gear that you can find. But they definitely do have a reputation, and they don't get the reputation for no reason either. They do cause a lot of trouble. Okay, so now that I have the basic recap out of the way, we are going to focus our attention to the back side of the board. We'll get that reflowed and defluxed, and then we'll move on to the switch. So what I like to do is I like to use liquid flux, and then I add some alcohol to a brush, and it allows me to spread the flux out over the entirety of the circuit board. And then what the alcohol will do is it'll just dry off and leave the flux residue behind. The phono head amp board is all set. I just reinstalled it. Looks good. All the connectors are back on. It's secured into place. I even polished the coupler and the shaft on the board side. Here's a look at the back of the board. Looks good. So I have the entire rear section of the preamp all set, from the power supply all the way up to the equalizer board. So now that that's all taken care of, I'm going to move my attention to the front side of the amp, which involves removing the faceplate and all these knobs and switches, the VU meter assembly, and that'll allow me to gain access to all the boards on the front side. So that should be pretty easy, considering it's all modular. So I will update you guys with a video as soon as I get to that point. I really can't stress how well built and beautiful this preamp is. I just removed the faceplate and the meter assembly from the inside, which is right here. This thing must weigh a pound or so. It's very heavy, all metal with a glass faceplate on it. Here's the faceplate right here. Solid aluminum. And here's what's underneath the meter assembly. Mostly just tone and volume settings, balance, all sorts of stuff. Beautiful ALP switches, all modular. And here's this board right here with a couple of these notoriously bad VD1221s, these double diode packages. There was also a couple on this board right here that I replaced with the common 1N4148 in series. Yeah, this thing is just beautiful. They do not make stuff like this anymore. And all these boards, they're all modular. Just pull the plug right off. You don't see that anywhere other than this old Japanese hi-fi equipment and aerospace. That's basically it. Test equipment. I mean, even this is nicer than a lot of test equipment that I've seen, even in the aerospace field. Just goes to show how much care and attention to detail they put into this equipment back then. Faceplate's in pretty good shape. Got maybe 1 or 2 nicks at the top, and that's about it. So this will clean up really nicely. I don't like the plastic because it scratches pretty easily, but this seems to be in pretty good shape. And I don't think I'm going to open this meter assembly. There's really nothing to do on the inside. So I'm just going to leave well enough alone. So when I get some of these boards removed, I will shoot a video and show you the process. So I just got the first board out, and I want to show you the whole subchassis actually swings out on a hinge once you remove the screws on the tops and the cross brace. Everything's modular. I mean, when I say everything, I mean everything is modular. It's really nice. It's really a work of art as far as I'm concerned. I mean, everything is right where you want it to be. All these boards aren't really mounted directly to the front plate. They have subplates. This is what I mean. So you don't have to remove every single screw for all the switches. You just remove the 3 screws that actually hold this plate in, for instance, and the entire board comes out with it as a whole module. That's how everything should be done. So I'm going to keep going. And yeah, should be fairly straightforward. One thing I'm going to have a challenge with is the light is burned out. I don't know if that's a neon light or if it's incandescent. If it's incandescent, I'll probably be able to do something about it. But we'll see. Okay, I'm back. It's the next day. I still have the front panel removed from the TAE-8450. Here are the circuit boards that I pulled out. I have most of these done. You can see I reworked the boards completely, reflowed and defluxed them, so they're all perfect. I found quite a few cracked solder joints on these, so I took care of all those. There were a few transistors in each of these circuit boards that I replaced that had black legs. Replaced them with new on-semis and Fairchilds, new Nichicon caps. Serviced all the switches and all these attenuators and selector switches. I also lubricated them so they're nice and free and they're smooth and they don't bind up anymore. A few of them did before. Got some new Muse caps there and some Muse bipolars. Here's the microphone input board, and you can see I polished these two microphone inputs right here, and I didn't polish this one just to illustrate the difference between the polished and unpolished, because when you get this all together, the last finishing touches like that make the appearance pop. Because when you see these dull inputs, it doesn't really look too good, especially when you clean everything else. So getting that done is it's a great, finishing touch. I also polished the contacts on the inside as well. And then here's the tone control circuit board, completely refreshed. I use the same deflux method I do for everything, just a few stages of an isopropyl bath with a paintbrush and a toothbrush and whatever else. This board right here took about 30 minutes to deflux. It's definitely a long process. If I had what do they call those things? Ultrasonic bath. If I had one of those, I'd probably use it, but I'm not a fan of using those on semiconductors. I think I've already gotten into this before, but most semis aren't really hermetically sealed, and the ultrasonic vibrations can actually cause moisture ingress. So I don't generally like to do that unless it's necessary. But yeah, I'm sure it would help out, but I get really good results just from using isopropyl and a toothbrush. Multi-stage process, but turns out really well. I've also had some comments from people saying that I should be putting conformal coating on these circuit boards. Don't do that. You don't need to do that. It just makes everything a lot harder to repair in the future, because then you have to start scraping the conformal coating and it'll just make it look like a total mess. You only really need conformal coating if you're in a really damp environment like in marine. I know aviation has a lot of conformal coating used because it's a lot more critical, and any moisture ingress, especially in those high impedance circuits, can be detrimental, so they coat the circuit boards in conformal coating. But in hi-fi equipment like this, don't do it. You don't need to do it. These aren't precision circuits, and it just makes everything a lot harder down the line. So just a reflow and a deflux is all you need to do. But yeah, it looks good so far. Serviced all the controls, all the switches. Everything is nice and smooth. This selector switch right here used to be very hard to turn, used to be really sticky, but now after I lubricated it and cleaned it, it's nice and free now. So the last board to do in the front before I get it all back together is the filter board. Have a lot of components on here to change out: transistors, capacitors, including a couple tantalums right there, and that one notoriously bad VD1221 double diode. That's right there, right in the middle. And this is a double-sided circuit board, so this is going to be pretty time-consuming to deflux because I have flux on both sides. So I'm going to keep going. I'm probably going to record quite a bit of the process of this circuit board right here, because I didn't record any of this. I've just been too busy. It takes quite a while to pull out the video camera and start recording the process and all that. So little bits and pieces here and there are what I prefer. Plus, this video is already going to be over an hour long anyway, so I'll keep going. So I'm all ready to start work on the filter board. Like I said, this is just going to get a pretty basic rework, including replacing these 4 blackleg transistors right here, the VD1221 diode that's in the middle, these 4 electrolytic caps right here that are in the signal path, these 2 tan looms right here, and then a basic rework of the circuit board with a deflux, as I usually do, as you guys have seen a million times. Other than that, I'm going to clean the switches, polish the headphone jack, service this potentiometer right here, and the related switch that's on the inside. So let's start it. I'm going to start off by replacing these 2 tan looms. So tan looms are polarized, so you can't just put a cap in either way. I've seen some people do that, and it's not good. So get these 2 removed, and I have some electrolytics to swap into their place. Some nice high quality Panasonic caps, super low ESR, super high performance. Next up, I'm going to replace all these electrolytic caps. These are low leakage caps by Nippon Chemicon, and these always go bad. The ESR raises, and then they become conductive, and they'll eventually actually start leaking. These will have a pretty major effect on the sound quality of the preamp. And in their place, I'm going to be using some Nichicon Muse capacitors, same value. I've had some questions about what solder I use. This is Kester solder. I think I'm using 6040 with a rosin core. Get the cleanest joints with this compared to some of the other solders on the market. For things like binding posts and RC ejects, I use Cardus Quad Eutectic solder. I find that it flows easier and it solidifies a lot quicker for larger jobs like that, so it's easier to work with. Okay, so now that all the capacitors are replaced, I'm going to move on to these transistors. These are 2SC1362, and you can tell that they're going bad because of the black legs. And you can see that component right in the middle. Where is it? Right there. That is a VD1221, and those are a double diode package, and those are notorious for going bad. So that's going to be swapped out as well. So I'm going to be replacing these 2SC1362s with gain-matched KSC 1845 FTA. The gain is very close, the pinout's the same, everything is on these is basically identical. They're a suitable drop-in replacement for most applications. So let's get these removed. Trying to stay on screen for you guys, it's kind of challenging to do that. Tell you what, this FR301 is one of the best tools I've ever bought, and that along with the FX951. They just make rework and repair so much easier. Sorry for the terrible video angle. Try my best, but sometimes you forget the camera's there recording with people watching. Alright, so the new transistors are installed. Now it's time to change out that VD1221. So the cathode is facing forward. Just throw all these parts in here. And to replace the VD1221, I've said before, I use two 1N4 1/4/8 in series. So here it is right here. These things are terrible, super unreliable, very notorious for failing and causing all sorts of issues. Alright, so that does it with the component replacement. All the components that needed to be changed out are now replaced. So now I'm going to work on the reflow and the deflux, and I will come back after I finish this board, because I know that process is pretty mundane, not really much to see. So I will be back when I complete that. Alright, so I have this board all set to go. As you saw, I just changed all the components out, and I finished the reflow and deflux process, and you can see that the board is not a matte green anymore. It's more of a shiny, deep, rich green that looks really good. All the solder joints are shiny and basically brand new. I found a few cracked joints while reflowing these, especially in the area of this switch right here. The contacts are nice and clean now. I polished them up. So yeah, this is ready to be reinstalled. It's just 3 screws and then the edge connector, and then it'll be good to go. All the controls are serviced and lubricated, as well as the potentiometer. The last thing I have to do is just polish up the input for the headphone jack, and that'll be good. So when I come back with the next video, this thing will probably be a little bit back together. I'll probably have this back on, and I'll be in a testing phase. So originally I didn't want to pull this thing apart, but looking online I can't find much information on these, and I thought it was interesting enough to take the risk to open it up. There is really not much to it. It's just 3 or 4 screws that hold the top lid on, and that just pulls right off. But I really wanted to share with you what actually makes this meter work. So on the front, it appears that there's just 2 digital readouts here, but this is actually light that's being projected from this light bulb right here, which goes across through this magnifying glass, hits this mirror, bounces off these 2 mirrors right here, one for left and right channel, and those bounce the light to this front display here, which then gives you your readout. So they're using 2 mirrors that are attached to these 2 little servos here, and I'll play some music just so you can see that. So yeah, I thought that was pretty interesting, and I know a few of you at least will get a kick out of that. During the day, this is actually pretty dim, and you can tell just by looking at it here. With the cover on, it's a little bit better, but I'm thinking about swapping this incandescent bulb out for an LED, just so we get some more brightness, as this light doesn't just create the projection, but it also shines through this diffuser here, and it lights up your display here. So I'm not usually a fan of putting LEDs in unless they're the right color temperature, but I think I can probably find one that will actually work in this application and give off some more brightness, because as of right now, during the day, this thing isn't that bright. So I'm going to put this back together, get it reinstalled into the chassis, and then do some calibration. But for now, this thing's working pretty well. We're back with the 8450. I have the faceplate reinstalled. with the knobs and the switches. I just finished a really deep cleaning and polishing of the knob, switches, and the faceplate, and everything looks really, really good. Super deep, rich grain on this faceplate. It's really, really aesthetically pleasing. It's really a gorgeous preamplifier. All the knobs and the controls are all serviced. Everything is nice and smooth. This selector switch right here for the treble used to be super sticky. It felt like somebody had honey in there, for lack of a better analogy, but yeah, it's nice and clicky now. All the controls are noiseless. There's no pops or clicks or static. The phono stage is dead silent, as well as the line stages. Everything's just working really, really well. So I was just following along the really comprehensive testing outline, as well as the adjustments for this preamp. Sony really went into pretty good detail about how to do all the testing, how to hook the preamplifier up for each individual test. They give you illustrations like this for things like the VU meter calibration. So I'll just show you. They have you calibrate the 0 point right there at the bottom for each meter. And then what they have you do is turn the volume up until you get 1 volt output. So there's about 1 volt right there. And they have you adjust the 2 meters for the 0 dB point, which I did. So yeah, it's really coming together. It's really starting to take form again after I had it all apart. Proper voltages in the power supply. Yeah, it's just really, really great. So after I finish the adjustments and the testing, I'm going to move on to the rear plate. This is going to need quite a bit of work. These use these really crappy plastic rivets that I'm going to have to pop out. Remove the entire rear board, rework the rear board. I'm sure I'm going to find quite a few broken solder joints, as these RCA jacks are directly soldered to that board. I have all these controls to clean. I think I'm actually going to bypass at least auxiliary 1. I think that's what the owner wanted, just to take that one little potentiometer out of the signal path. Although I'm not sure yet. I might just leave it. But yeah, tons of controls and switches back here. And of course the IEC inlet. I'm going to put a new power inlet in this. Remove this old cord. Oh, this is a pretty nice cord. It's pretty thick for what this preamp is. And you know, the current that it draws, in other words. So yeah, this is going to be the last stage of this preamplifier's restoration. Other than that, it's looking really good. Oh, I almost forgot to show. I have a new light in the front power button there. It's not as bright as it looks on video. It's kind of oversaturating. But I used a drop-in resistor with a green LED, and that fuses with the diffusers that are in the button itself, and it looks pretty good. From the other Sonys I've seen, this is a little bit of a deeper green instead of a teal, which I like quite a bit. It's not totally different, but yeah, it looks really good. So yeah, I have that all tied up, heat shrunk, looks really good. So I'll follow up with a video pretty shortly of my progress with the rear panel. But yeah, other than that, I'm really happy so far. So in preparation of installing the IEC, I have the power cord cut off, and I have the rear plate loosened on each side. And I want to show you the fact that this thing has hinges in it. You can just hinge it right down, and that gives you access to all your circuit board, your power input, your voltage selector right here, and all these connectors on the circuit board just pull right off. You just get all these plastic rivets off, loosen these nuts that hold on these switches and potentiometers, and this whole circuit board comes right out. Pretty cool. Super service friendly, just as the rest of this thing is. Looks like I'm going to have plenty of room to install the IEC inlet, so that'll go pretty smoothly. So yeah, I'll come back in a minute. So as I was just saying, Sony decided to use these really crappy push-on plastic rivets, but something cool that they did was they put holes in the PCB where each one of those rivets is. So you can just take a small tool, like a flat-bladed screwdriver, reach in here, push the rivet out, and boom. Simple as that. Instead of trying to fight with these and try to stick something under there and risk scratching the plate, you just push it right through. The other equipment that I've worked on never had that, so I guess they realized how shitty it was to use plastic rivets, or try to get them out anyway. I'm not sure why they used them. Really unsure. One screws would have just worked as good and, you know, been super service friendly, but whatever. They work, and because they did that, it's a lot easier to take out. Okay, so after getting all these rivets removed, all that's left are going to be these nuts that hold the potentiometers to the rib plate, and these two screws that hold the sensitivity switches as well. I have the impedance selector switch removed, as that was a separate piece that was just floating. So now that that's out of my way, I'm going to remove these shaft hold down nuts, and that should be it, as well as these two screws. That should be it. Someone's definitely worked on this board before. All these solder joints have been touched up. Definitely not factory. So I'm going to get to reworking this board. And I'm also going to polish up all these RCA jacks as well. And I have a bunch of potentiometers to service as well. So I'm going to get to it. So I got a little carried away, and I forgot to take video as I went. But I just got this rear panel all set. You can see it looks brand new. I have the IEC inlet installed. All the RCA jacks are nice and polished. RCA plugs go on and come off very easily now. All these trimmers, this switch, and these two sensitivity rocker switches are nice and smooth, all serviced. I have the rear plate polished as well. As you can see, it's nice and shiny now. Yeah, this thing's amazing. This thing's ready to go. And take the top cover off. I wish I grabbed some video of the circuit board rework, but that went really well. The board came out really, really nice. If I have photos, I'll include them here, but I don't think I took photos. But yeah, that's all set. So yeah, this thing's ready to go. You can see all the controls are nice and clean now. There's no gunk in them anymore. I adjusted the dropping resistor on the power LED. I dimmed it down just a bit more, made it a little bit more subtle, so that looks good now. And what I did was I ordered these LEDs on the internet. I ordered a couple different styles for the meter up front, because I did notice that it was pretty dim in the daylight. But because of the setup with the mirrors, you really need to use an incandescent light. It's really, what's the word I'm looking for? It's very sensitive when it comes to directionality of light. And the incandescent just has a pattern to it, I guess, that works much better than LEDs will. So I could never get the two bars to focus, because you have a focus adjust up top. But it didn't work out well. I tried both. Even this LED kit right here that has the LEDs much closer together and more of them than this right here that only has 4 LEDs per bulb. It worked a bit better, but it it still didn't look good because you just couldn't get them to focus. So I put the original incandescent bulb back in, and that's just how it's going to have to be. It's definitely legible. You can read it, and it's definitely it works. But I don't know. I would just like it to be a bit brighter, but can't do it. So just going to have to live with it. It looks good either way. So, but yeah, I'm very, very happy with this thing. I sent some photos to the owner, and he's ecstatic. So, yeah. So I'm going to pop the top cover back on, and as usual, let's take a listen to it. And just before I forget, I just want to show the parts that I replaced. Lots of tantalum caps, electrolytic caps, transistors, a ton of these VD1212 diodes that are really notorious for going bad. Lots of carbon comp resistors, diodes, all sorts of stuff. Yeah, lots of these orange caps that just measure terribly. So yeah, this thing's really fully restored now. It's definitely ready to go for the next few decades anyway. Probably more. I mean, this thing will probably last another lifetime. And here's just a shot of that power LED before I forget as well. But you'll see that in a second anyway. And here's the VU meters. It's weird, if you look at them directly on, they're a bit dim, but if you go off to the side, they brighten up. And as the meters go further up the scale, they do get brighter. I did notice that. So, all right, let's get it popped into the system and take a listen. And really quick, just before I get it in my system, I just want to show some distortion measurements of the 8450. So I'm feeding a 1 kilohertz signal in, and the output is basically at 0 dBV. And you can see the distortion is 0.017%, A-weighted, and they give a figure of 0.03%. So this preamp is running very well in both channels, better than spec from the factory. So let me switch these out to the other channel, and you'll see that both channels are basically dead even. So that's a very good sign. This preamplifier is working perfectly well. The phono stage measures perfectly fine too. So just goes to show a restoration like this isn't just for reliability enhancement. You're also going to get much better measure performance with the replacement of all those old out of tolerance parts. So, all right, let's get it into the system. All right, I'm back. I have the 8450 in my system. I have it all buttoned up, and it looks really good, especially with the sunlight reflecting off the faceplate. So good. Those VU meters are working, and they look really good. The power indicator turned out well. It's nice, deep, rich green color. All the controls are noiseless. Nice and smooth. The wood sides are nice and rich and deep now that I waxed them. The rear panel turned out well, as you saw. Yeah, I couldn't be happier with this thing. The owner's going to be out of his mind happy too. And it's going to be a great match for the TAN-8550 when this one's all set to go. This one's going to be up next. Quite a bit of work to do to this one. Somebody's already worked on this one before, so I'm going to have to go back through and redo all that work too, because I see some pretty nasty stuff going on inside of this one. So that's going to be next, and then the AEG10 is going to be after that, the flagship Onkyo integrated amp. So yeah, got some cool videos coming up, but for now this thing is just perfect. So I'm going to end the video there. I appreciate the support you know, the comments, the likes, the engagement with all the videos. It's really cool to see the conversation that these videos create. I know a lot of people enjoy this type of content, so I'm going to keep it coming. And yeah, I enjoy working on the higher end equipment like this Sony here. It's always fun to work on. I try not to work on any of the lower end stuff, you know, the cheap receivers and the you know, cheaper equipment. I always find that working on the flagship stuff, it's always the most satisfying while working on it and seeing the final product. So, all right, thanks for watching, and I'll see you guys soon. I'll leave you off with the view meters here.